Parent. I know how tired your parents are. I know how hard they work. But if you've been having honest discussions with your parents about your schooling and the issues that are faced by school districts like Patchogue Medford, it's not just Patchogue Medford, it's all of the districts around here. On Thursday night, our superintendent, Dr. Hines, and several other superintendents from across Long Island, plus some local leaders, by that I mean many towns, not just Patchogue, the news, a lot of people are going to be there. Saxton Auditorium, 7 o'clock. And if your parents are interested in what's going on and want to learn more about the state of education and trying to do the best they can for you, if your parents are interested in that, I would recommend that they show up at Saxton on Thursday at 7 o'clock. Okay? You get the fireside chats on Sunday nights, right? You know, Dr. Hines calls your house. You know those, hello, Patchogue Medford community. This is Dr. Hines with your Sunday night 7 o'clock fireside chat. You haven't heard those yet? Okay, well, he mentioned it on this week's fireside chat, and he'll probably do another phone call home today or tomorrow to remind parents one more time. But it's going to be, I think, an event to be seen. Now, let's see here. We're not quite ready for the do it. We need to go through the quizzes. I think most people got the first question right on the quiz. What was the correct answer? Somebody raise their hand. Let me know. Michael?
C.
Why is C the correct answer?
Because each one has its own specific number.
That's right. Every input, the X's, all have their own unique output. No X has two different outputs, right? We can't have that. So number one is choice C, and I think just about every person got number one right. I think in both classes combined, there's a total of about 43 kids or so, 44 kids, and in all of those classes, I don't think more than one or two kids missed question one. So we're good as far as that goes. On the other hand, there's question two. I expected difficulty on question two, and I do not believe you're the problem. I believe I'm the problem. If you got it right, awesome. If you got lucky, well, we'll get to all of them.
Yeah.
If you got lucky on number two, your lucky day. How many people felt they really knew how to do number two? How'd you do it?
I like at first I checked all of the answers and then I saw how there was differences. And each of the squared or whatever they are on the side were different. So I just added all these up and
All right, that's definitely
yeah,
not how
that
you
was
do it.
easier though.
Yeah, definitely not how you do it.
It was
Okay,
still an easy way.
now, the way to do a question like this, we've said many, many times that we can get confused when they start expressing things in scientific notation. So let's keep it simple. You ready? At a given time, Saturn was, instead of using scientific notation, I'm going to say 10 miles away from the sun. And the Earth was 8 miles away from the sun. How much further is Saturn than the Earth? If Saturn's 10 miles away and the Earth is 8 miles away, how much further is Saturn? 2. How'd you get 2? Subtract. So I have to subtract these numbers. Now the problem is, I taught you how to multiply scientific notation. I taught you how to divide scientific notation. We've done a million examples so far this year about multiplying and dividing scientific notation, but we've only done a handful of adding and subtracting. Whenever you're going to add or subtract with scientific notation, you have to first convert, or it's best to first convert back to standard notation, regular notation. So I look at the first number here, and it says 9.1 times 10 to the 8th. And then I look at the second number, and it says 9.3 times 10 to the 7th. Which of those two numbers is bigger? The top one or the bottom one? Top one. How do you know the top one's bigger? Higher exponent, right? Okay. Now, 9, 1, 2, 3, 4, 5, 6, 7, 8. And then this one only goes 7 places. So 1, 2, 3, 4, 5, 6, and then 3, 7. And then I just subtract. 0, 0, 0, 0, 0, 0. Oh, I like that subtraction. Now, this is gonna become 10 minus 3 is 7, and then 90 minus 9 is 81. So I get 817, but they don't give me choices that look like that. So now I have to convert this to scientific notation again, convert back. 3, 6, 7, 8. 8.17 times 10 to the 8th. Now, as you look at that, how many people think that's like impossible? How many people look at that and go, oh man, I don't know if I'll ever be smart enough to do that?
They gave a choice.
Now, how many people look at it and go, I don't really remember much about doing that? Because I think it's the last case, and I think it's my fault. But we're covering it now, and you can bet we're gonna cover it a bunch more between now and the state assessment and then the end of the year, because I did notice on the handful of state assessment questions that they released, there were 2 or 3 like this, where you needed to add or subtract. So I wanna make sure we emphasize how to do this, and I don't think I've done a good enough job of teaching you how to do that, okay? So you write them out as regular standard numerals, you do your subtraction, you convert back to scientific notation. Okay, any question about that? Okay, let's go now to number 3 with the goldfish. Now, there's 2 ways to do the goldfish question. Back in the day, before such things as Twitter existed, that was not called hashtag. It was a symbol for number.
Yeah.
Yup, I don't know if you knew that or not.
I still
Eleven
use
is
it as
active.
number. I don't use it for hashtag.
Yeah. Okay. So, there's a couple of different ways to do this question. The way to do it so that you don't need like a multiple choice is to be able to just fill it all out. And look, this is like a table, and they're talking about the rate of change, the cost for each goldfish. Mr. Middledorf, you with me here, bud? Look like you're zoning out on me. What is the cost going up by each time? No, not $2. $1.50, good. $1.50. And how much is the goldfish going up each time? 5. All right, so if it's going up by $1.50 for every 5 goldfish, this is the rate of change, right? Slope is like rate of change in Y or change in cost over the number of goldfish. $1.50 divided by 5 goldfish means for every goldfish it goes up 30 cents. Okay? Now, let's take a look. That's one way to do it, and I think it's a great way to do it. But let's look at the choices. I don't want to go with choice A first, because that's the actual answer. So let's look at choice B. Does the cost increase $1.50 every time a goldfish is added? Now, if you look at the cost, it is going up $1.50 every time, right? But is only 1 goldfish being added? No. How many goldfish are being added? 5. So that can't be the right answer. The next one says it goes up $3 every time 5 goldfish are added. So here now I'm going up by 5 goldfish, but am I going up by $3?
No.
No, so that can't be it. Well, the next choice says you're going up by $6. Am I going up by $6? No. But choice A says it's 30 cents every time a goldfish is added. And that's what we came up with, $1.50 divided by the 5 goldfish. So it's 30 cents every time a goldfish is added. Any question on that one? Okay. A number of people missed number 3, and I'm hoping that when you get tomorrow's quiz, you have a little better interpretation of that table. Now, let's turn to the back on number 4. So here's the graph,
That one was easy.
and it says, what's the ordered pair that is the solution? And some people put choice D. It's choice B. It's always, guys, X comma Y. They meet at the point right here. It's the X, then the Y. If you trace that down, look on your paper, trace that down.
It looks like a G.
What's the X value when you get to here, guys? Tracing your paper, go straight down. What's the X value?
4,
4. And then across, what's the Y value?
10.
10. So they meet at 4, 10, which is choice B.
Can I look?
Talia, there's an extra one right there. You can grab one, and obviously it won't count, but you can study it for tomorrow, okay? And if you want, you can watch the video at home and go over this. Yes, I know, it looks like a G. My handwriting's off.
Heads up, don't go to IHOP later.
What was that?
Heads up, don't go to IHOP later.
Don't go to IHOP later?
It's free pancakes today, and me and my, not my brother, my cousin went there. That's why I'm so late. There must have been like 50 people waiting at like 9 o'clock in the morning. Like, I could not believe how many people there were.
Yeah.
Try right there.
You know what, I'll tell you what about pancakes, I don't eat them very often.
I
I love them, I love them. I don't eat them very often. And I really don't like to eat them unless I'm home because my buddy gets the real maple syrup out of the tree,
Yeah.
and it's so much better than the stuff you get at a store or a pancake house, that I just want my special maple syrup when I do this, so I have it at home. Every year
I
he
would
gets
just
me a
bring
jug
it
of
with.
stuff. What's that?
I would just bring it with.
Yeah, right, okay. The triangle has sides with lanes 4, 7, and 10. Is this triangle a right triangle, why or why not? So lately, we have talked a lot about right triangles.
We're talking
And
about
we-
a lot of triangles just in general.
Yes, but specifically right triangles, there's something that always works in a right triangle. What's that thing we learned that always, always, always works in a right triangle? Michael?
The hypotenuse theorem.
It's not called the hypotenuse theorem. Theorem is it, but it starts with a P in the front. Pythagorean theorem, very good. Now, hypotenuse is part of that. Legs squared plus legs squared is hypotenuse squared. And the hypotenuse is always the longest side. So let's just plug the numbers in and see if it checks. If it checks, we know it's a right triangle. If it does not check, then what? It's not a right triangle. So, does 4 squared plus 7 squared equal 10 squared? What's 4 squared? 16. What's 7 squared? 49. And what's 10 squared? Is that true? Does 16 plus 49 equal 100?
No.
No. Therefore, it's not a right triangle. Okay? All right. Now let's go to number 2. And this is just a very important question. I don't know if you realize this or not, but we are forbidden, we teachers are forbidden, absolutely forbidden, to talk to you about the questions on your state assessment exam. By law, I can be fired if I talk to you about it. It's terrible. So the only questions I can talk to you about are questions that the state releases to the public. And the state has released several questions like this one to the public. So I think it's really important that I prepare you for these kind of questions, okay? Now, when we look at this, I'm going to draw a line on this right now. Just real quick on your paper, write down what the rate of change of that line is.
Where the draw the line?
If you want, you know, that's not a big deal. I just want to see that you can recognize what the rate of change is. What's another word for rate of change, everybody?
Slopes.
Slope, good. What is the slope or rate of change in A? I just drew it. What is it, everybody? 1/3, good. What's the rate of change in letter B?
5/2.
Okay, can we have more than just Michael helping me out here? 5/2.
Yeah.
In C, what am I going up by here? 3, and what am I going up by here? 1, and the slope is change in y over change in x, so that's 3/1. So now the next question is, since it wants the greatest rate of change, by the way, we've now done the 8th grade part of this question. We're now dropping down to the 4th grade part of this question, and this is the part where kids get it wrong. How many people got those numbers right?
Me.
Right, did you all pretty much get them right?
Yep.
Okay. Which is the greatest number there?
3/1.
Very good, because you know what a lot of people say? 5/2.
Because that was
Lots of people say 5/2. They look at the 5 in the top and they say that's the biggest one. Well, what if I said 5/10 billion? Would it still be the biggest one?
No.
No. So in other words, to see which one's the biggest one, I also have to think about the denominator. Now, one way to do this is I could like divide, make a gazenta house here. 2 gazenta 5, and I get 2.5. What's bigger, 3 or 2.5? 3. Another way, 1 times what gets me 2? 1 times what is 2? 2. So 3 times 2 is 6. What's bigger, 6/2 or 5/2?
6/2.
See, the only way you could say that a fraction is bigger if the numerator is bigger is if the denominators are the same. So when you get the same denominator of 2, then you could say, aha! That one's bigger. That has to be the bigger one. But until you get the denominators the same, it's not there. For instance, check this out.
5/2 is the same.
Which is bigger? 2 over 1. What's bigger, 99 or 2? 99. But the fraction value, 2 is bigger. 99 over 1,000 isn't even a whole. It's actually less than a tenth. It's really tiny. This guy, that's 2 wholes. Okay? All right. So, now, let's go to today's lesson. Whoop, watch those feet.
You always trip over my feet.
Yes, and whose fault is that? Yeah, right. Okay, so now we're going to talk about symmetry.
What's with all the numbers and letters and letters?
Oh, we have to learn about symmetry before we can go forward here.
What is this thing? That's not even an X, that's like
That
a
isn't
dimension.
even a symbol.
Yeah, this is actually a Hebrew symbol,
Hey, it looks like a trident.
and this is a Greek symbol.
Isn't
Okay.
that the candle?
Yeah, like the menorah? No, there's a few more of them
It's
on
a
that.
trident.
Okay, look,
I thought it was that.
here's the deal.
It's like a triangle.
Symmetry, you have symmetry. You are born with symmetry.
Yes, of course we are.
Yes, see, look. I'm actually not quite symmetric because one of my legs is shorter than the other from my accident, but I was born with symmetry. Now, if we drew a line straight down the middle of your body, you're the same on both sides of that line. Ear, ear. Nostril, nostril.
Wait,
Well, you have a mole on
isn't
one
like,
side of your face
like
and not on the
sometimes
other,
isn't
so.
your one ear bigger than the other one or things like that?
Without getting out of micrometer, let's just go based on
Yeah, so
general
you have a
impression.
mole on one side of your face
Yes,
and not
but I wasn't born that way. And that was actually, you know how I got that?
Oh.
I was shaving and I ripped open my skin and it grew back with what you call a little keloid. Then I went to the doctor and the doctor cut half of it off. He didn't cut the whole thing. I went to him, he numbed it, he cut half of it off, and I said, why'd you only take half? He goes, well, I want you to come back and take the other half. I want you to come back and then I'll take the other half. I said, why would you do that? He says, take a guess. I said, so you can get twice the money? He said, absolutely. So I said, I ain't coming back. So if I get a dermatologist I like, I'll go back to that dermatologist and I'll let him cut it off. Now, anyway, here's the deal. We're born the same way. Ear, ear, nostril, nostril, eye, eye. Imagine, if you will, if the eye switched with the nostril on this side.
Oh, that would be.
Now, can you imagine if you sneezed? How disgusting would that be? You'd be like, oh God, oh, I got this thick film on my eye. I can't see a blessed thing. So you definitely, absolutely are born with symmetry, and it's really helpful. Imagine, if you would, if we took your right leg and switched it with your right arm.
Oh, that would just be
That'd be
so
funny.
hard
You'd
to
be
How the
like,
heck would you
la, la,
walk?
la,
Right, well, you'd be really good at Twister. Right? That would work. So,
Unless you had your arm on your head, that would be.
yeah, right. All right. So, what about a knee replacement? How would that work? So, symmetry means the same on both sides. So, if I drew a vertical line, remember vertical is up and down. If I drew a vertical line through this figure, do you see how it matches on both sides? As if I folded it over that line, it would be the same on both sides. That's what symmetry means. Turn to your partner or someone sitting around you and say, symmetry means same on both sides.
Symmetry means
Okay, now I need you to write the word symmetry on your paper. Write the word symmetry on your paper. This is all the swirl thing, right? Speak it, we said the word symmetry. Write it, you're doing that now. Read it, we read it over there, symmetry means, and then listen, and obviously you're hearing me. So, this is the way we get you to learn new words. We swirl. In fact, I'm going to tell the whole staff about swirling today. So, symmetry is the same on both sides. What's symmetry again, one more time?
Same on both
Same on
sides.
both sides, very good. So now, if I draw a line through A, there's my vertical line, pretend it's straight up and down. Does that have vertical line symmetry?
yeah.
Yes.
Of course.
Does T have vertical line symmetry?
Yes.
Yeah, right down there. Okay, good. What about D?
No.
No. But D does have symmetry. It has horizontal line symmetry. So there's two main types that we talk about at our grade level. We talk about vertical line symmetry and horizontal line symmetry. What about the letter E? Does it have vertical, horizontal, both, or none?
Horizontal.
Horizontal. What about H? Both. What about Y? Vertical. P? None. There's no symmetry with the letter P. Now, K is an interesting case. The way they formed it here, there's no symmetry. But you know how most of us write it so it comes like in there? If you put it so that they meet each other here rather than up the line a little bit, then it would have horizontal line symmetry. And what about B?
Yes.
Horizontal line symmetry, good, right through there. Okay, so you should be able to recognize horizontal and vertical line symmetry. That was the first thing that we're supposed to be able to do today.
So we guys forget
What would the letter X have?
graph.
Both,
Both.
right? Yeah, horizontal and vertical line symmetry, good. What about the letter N? None, right? So if I go horizontal, then this would be down there and it doesn't match. And if I go vertical, then this would be over there, that doesn't match. So there is no vertical or horizontal symmetry with the letter N. There is this thing called point symmetry, but we don't really talk about it. That's the thing that looks like there ought to be symmetry, but it's point and not line. So we only talk about line symmetry.
There's graph symmetry.
Yeah, well, that gets us to the next thing. Another place we can find symmetry is on a graph. So what I'd like you to do now is plot the points 5, 2, 7, 5, 1, 6, label them A, B, C.
Okay.
Okay, does everybody have the same triangle ABC? Now, as I look down on a few of your papers, one of the things that I see, or some of the things I see that are missing, are the A, the B, and the C. It's important to put the letters on the points too. So write A, B, and C next to each of those points. Eric, right? You did?
Yeah.
Oh, I can't even see them from here, okay. All right, so now if we look at what part B says, what does part B say? All right, stop right there. What does reflect mean? Go ahead.
Like a mirror, like do the same thing.
Excellent usage of the word reflect. In a mirror, you see your reflection. So
It's
reflecting is
opposite.
kind of like with a mirror, opposite, good word, opposite. When you reflect, you see what we would call a mirror image, right? Okay. In mathematics, a reflection is a flip. Everybody say a reflection is a flip.
Reflection is a flip.
And when we do reflection, what I like to do is what we call count and repeat. So write this in somewhere on the blank area of your page, right? Reflect, count, and repeat. Everybody write that down. Reflect, count, and repeat. Now, what are we going to reflect over here? I stopped you after the first word. It says reflect what? Triangle ABC over the x-axis and call this a prime, B prime, C prime. Good. So I'm going to reflect over the x-axis, which means the x-axis is going to be like the mirror. And I want to be the same on both sides of the x-axis. In other words, the x-axis is going to be like a line of symmetry when I'm done with the figure. And all I'm going to do is this count and repeat. This is so easy. This is like the easiest thing you do all year long. Can everybody here count? Let's count together. Ready? 1, 2, 3, 4. Now let's repeat. Ready? 1, 2, 3, 4. If I say 5, did I repeat?
No.
No. Gotta be the same amount. So if I'm going to reflect over the x-axis, I'm going to count and repeat. Check it out. Ready?
But if you count back.
Hold on. Ready? 1, 2. Then what am I going to do? 1, 2. I counted 2, and I repeated 2. Oh, I gotta sit down.
Oh my god, here we go.
That took all my mental strength. I think I'm white.
You're
Anybody
going
else
there
mentally
already.
exhausted right now?
No.
Good. Flip B.
I already
Reflect
did
B over the. Oh, we got Annabella racing ahead here. All right.
I'm
So.
already on C.
Oh, there you go. All right. So now we're going to count and repeat. What do you do every time you do a reflection?
Count and repeat.
Count and repeat. What do you do every time you do a reflection?
Count
I'm waiting for Middledorf to answer and Leah, the two quietest kids in the class. What do you do every time you reflect? Count and repeat. Very good. Ready?
I'm done.
1, 2, 3, 4, 5. 1, 2, 3, 4, 5. B prime. Now let's do the C. Ready? 1, 2, 3, 4, 5, 6. What do I do now? 1, 2, 3, 4, 5, 6.
Yeah.
C prime. Now doesn't this look the same on both sides?
Just opposite.
Yeah, so you create symmetry, right? That is a reflection over the x-axis. Now, does part C say to reflect it over the y-axis? Oh, no, it says write the coordinates, okay? So let's write the coordinates now. We started with, hold on here. A was 5, 2, B was 7, 5, and C was 1, 6. Now, what are the coordinates for A prime? What are the coordinates right here, guys? Here's A prime. What are those coordinates? 5, negative 2. What's B prime? Here's B prime right here. What are those coordinates? 7 what? Negative 5. Good. And what's C prime going to be? 1, negative 6. Does anybody see a pattern? I love patterns. I love seeing patterns. Patterns are cool to me.
The X's are all positive.
Okay, well, not only are they positive, they're what?
the same.
The same. What happens to the Y's?
They become negative.
They become negative. So in general, if I had XY, it becomes what? X
Negative.
negative Y. Very good. That's what part C was looking for. Okay? Now what we want you to do, take the original triangle, triangle ABC, there it is, the blue one. Now I want you to flip or reflect it over not the x-axis, but which axis this time? The y-axis. So again, count and repeat over the y-axis. And this time we're not going to call it A prime, B prime, C prime. We're going to call it A double prime. B double prime, C double prime. Do it. Talia, you're doing the wrong one. You want to do the blue one.
Oh.
Is everybody getting the green triangle? Take a look at your papers. Everybody getting the green triangle? Right? We're good? Okay. I just want to go forward and I want to do number 1 in the next section before the period ends, and it's going to end very quickly. So, which of the choices below looks like a reflection? A, B, or C? Which one of those looks like a reflection? B, right? Because you're flipping it across that line? Very good. Okay, so do a great job on tonight's homework. Remember, if you have any other missing homework, let's get them in as soon as we can. Hasta la vista. What's that?
I see you tomorrow or tonight?
Tomorrow, Wednesday. Hasta la vista. Vaya con Dios, Toodaloo. Ta-ta.